All right, welcome to the Explainer. Today, we're diving into a new AI coding model that's, well, it's punching way above its weight class. It's small, it's super efficient, and honestly, its performance is turning a lot of heads. So let's just start with a thought experiment. What if you could get the power of a really top-tier AI coding assistant? Something that can write seriously complex code, build entire websites, and even optimize databases for you. And then, what if all that power didn't need a huge, expensive server farm to run? What if you could just have it right there on your own machine, ready to go whenever you are? And that really gets to the heart of the dilemma in AI development right now. For a long, long time, the basic rule has been pretty simple. Bigger is better. But that bigness comes at a ridiculously high computational cost. Yeah, for years, the best and biggest AI models have been kind of locked away behind these huge financial and computational walls. They need an incredible amount of energy, specialized hardware. It just makes them completely inaccessible for a lot of individual developers, researchers, and smaller companies. But a new model has just stepped into the ring, and it's basically challenging that whole idea. It's built on a philosophy of efficiency, trying to deliver that top-tier performance without the top-tier price tag. It's called Qwen3 Coder Next. Yeah, try saying that 3 times fast. And it is built from the ground up to be a lean, mean coding machine. It's really designed for the real world, for developers running code right in their own IDEs, and for building those smart, autonomous coding agents we hear so much about. Now, this number right here, 3 billion, this is the key to its incredible efficiency, but it is not what you might think it is. So, get this, while the total model has a whopping 80 billion parameters, it only ever activates a tiny fraction of them, just 3 billion, at any given time when it's actually running and generating code. I mean, that is an absolute game changer for how many resources it uses. So how in the world does it pull off this magic trick, right? How can it use so few active parameters and still go head-to-head with the giants of the industry? Well, the answer is in its architecture. It's called a mixture of experts, or MOE. Think of it like a giant company with 512 different specialist departments. Now, when a coding problem comes in, instead of waking up the entire company, the system is smart. It intelligently routes the problem to only the 10 most relevant departments, while literally everyone else just stays on standby. Okay, so let's dive into this. It's efficient, we get it, but how does this underdog actually perform when you give it real-world, complex tasks? Because this is where things get really, really impressive. First up, it was tasked with writing a C++ solution for a pretty tricky problem, finding a distinct subsequence in a string. And this isn't some simple script. This requires some really solid algorithmic thinking. And wow, the results just speak for themselves. The model produced clean, optimized, and totally correct code. And it even showed signs of self-correction as it was generating it. That's a sign of some seriously high-level reasoning going on. So for the next test, the challenge was upped a lot. It was asked to create a sleek, modern, interactive landing page for a fictional electric vehicle startup, complete with animations and responsive design. The result? A production-quality, fully animated, and responsive web page, all generated in a single HTML file. It had dynamic charts, smooth animations, and a really modern look, just way beyond what you'd ever expect from a model of this size. And finally, it was challenged with a notoriously difficult task, one that trips up even a lot of senior developers, optimizing a complex and really inefficient SQL query. And here's the really crucial part. It didn't just fix the query. No, it correctly identified multiple, deep-seated issues and provided this comprehensive production-quality advice, even including advanced recommendations for database indexing. Okay, so these individual tests are pretty impressive, but what about the bigger picture? How does this model actually stack up against the industry heavyweights when you look at standardized benchmarks? Well, on the super demanding Sweetbench Pro benchmark, which measures coding proficiency, it scores a remarkable 44. That puts it right alongside giants like Claude 3 Opus, and it actually beats some much, much larger models, all while using that tiny fraction of active parameters. This incredible balance of power and efficiency places it on what's known in economics and engineering as the Pareto frontier. It's the sweet spot. It's that optimal line where you get the most performance for the least amount of computational cost. It's delivering near top-tier results at a total bargain price. And that kind of leaves us with a final thought. Does the success of lean, efficient, specialized models like this signal a fundamental shift? It really seems like the future of AI isn't going to be about brute force, but about brilliant, efficient design.